The topic is homogeneous linear equations with constant coefficients, second order DEs, and we're doing the case of conjugate complex roots. So let's read the definition. Definition says, if a differential equation has the form A, second derivative of y plus b, first derivative of y plus cy equals 0, then the auxiliary equation would be am squared plus bm plus c equals 0. And in the case of two conjugate complex roots, which is f1 plus I beta, the first root, and the second one alpha minus I beta, then the solution will be y equal e to the alpha x factor of c1 cosine of beta x plus c2 sine of beta x. So let's do this example. Solve for second derivative of y plus 2 first derivative of y plus y equals 0. So definitely the auxiliary equation will be a, which is 4, times m squared plus b, which is 2, times m plus c, which is 1, is equal 0. So let's use quadratic formula to solve the auxiliary equation. Now m is equal minus b minus plus square root b squared minus 4 times a times c over 2 times a. Now this is equal minus 2 minus plus square root 4 minus 16 is minus 12. For 2 times 4 is 8. So m is equal minus 2 minus plus square root of negative 12 is I square root of 12 over 8. Now remember, square root of 12 is square root of 4 square root of 3, which is 2 square root of 3. So this is equal minus 2 minus plus I times 2 square root of 3, everything over 8. Now so m1 is equal minus 2 over 8 minus 2 square root of 3 over 8i, and then m2 is equal minus 2 over 8 plus 2 square root of 3 over 8 times I. Now let's simplify it more. So m1 is equal minus 2 over 8 is negative 1 over 4. Simplify the 2, you get 2 square root of 3 over 4i. And same thing here, m2 is equal negative 1 over 4 plus square root of 3 over 4i. So now just by looking at m1 and m2, you can tell this is my alpha and this is my beta, right? So alpha and then beta. So now I know my alpha is equal negative 1 over 4. My beta is equal square root of 3 over 4. What does I need? That's all I need. Now let's go back to the solution, which is right here. So the solution is y is equal e alpha x factor of c1 cosine of beta x plus c2 sine of beta x. So all I do, I plug in my alpha here, plug in my beta there, and my beta there, and I'm done. Now y is equal e, my alpha is negative 1 over 4, so negative 1 over 4x, factor of c1 cosine, my beta is square root of 3 over 4 x plus c2 sine, my beta is at square root of 3 over 4x, and I'm done. So this is my general solution. And that's it for this example.